Hi friends, myself Santoro. My domain is mobile computing. My project title is virtual backbone construction with guaranteed routing cost in mannet. The main aim of this project is to reduce routing cost, power consumption, bandwidth and interference. Then construct only limited number of virtual backbones, which is optimal for network. Then I am going to implement all these in directional antenna. The main problem is in wireless data transmission is finding the adjacent node. Without finding the adjacent node, we cannot able to transmit the data from source to destination. For avoiding that, I am constructing virtual backbone between the source and the destination node. If we construct virtual backbone between the nodes means we can easily find out the adjacent node. So we can transmit the data from source to destination in an efficient manner. Existing system. In the existing system also uses directional antenna for data transmission, and also it uses more number of virtual backbones. So it occurs conflict, and also the topology change is very difficult, and also it requires more cost for constructing more number of virtual backbone, and also it does not provide efficient routing. So the routing cost is high, and also it takes more time for data transmission. In my proposed system, I am using some efficient algorithm for routing. So the routing cost is low, and also I am constructing only limited number of virtual backbones. So it is optimal for network, and also it does not occur conflict, and also it does not require more cost for constructing the virtual backbone. Then I am using directional antenna for data transmission so that power and the bandwidth are not get wasted. These are my literature survey. These are my hardware and software requirements. This is my system architecture. The yellow color region represents the coverage region. The directional antenna is used for data transmission in my project. If the left side of the directional antenna has forest means, and the right side of the antenna has city means, the left side has forest, so it does not require any signal. So directional antenna has two modes: power on and power off mode. The forest region does not require signal, so we can off the signal in those regions. So the power and the bandwidth are not get wasted. Then I am using iterative and adaptive algorithm, which is used for constructing a virtual backbone, and also which is used for constructing a limited number of virtual backbones. Then genetic algorithm, which is used for next backbone generation. Then random greedy assignment algorithm, which is used for associate regular node to backbone node. Finally, alpha minima routing algorithm, which is used for transmitting the data from source to destination in efficient manner. This is my system flow diagram. Initially, I am transmitting the signal by using directional antenna. It has two modes, power on and power off mode. If we want signal, we can on. If we does not want signal means we can off the signal. Because of this, the power and the bandwidth are not get wasted. Then node prediction using genetic algorithm. If we predict the adjacent node, then only we can able to transmit the data from source to destination. And also for virtual backbone construction, initially we have to predict the node. How I am predicting the node means, initially I am sending request to the adjacent node. After receiving acknowledgement from the node, I am extracting the IP address. By extracting the IP address, I am finding the adjacent node. Then construct a limited number of virtual backbone using iterative and adaptive algorithm. If I construct more number of virtual backbone means it occurs conflict and also it requires more cost. So only I am constructing a limited number of virtual backbone. Limited number of virtual backbone avoids conflict. Then, after considering the limited number of virtual backbones, the data are transmitted through the virtual backbone. Finally, I am using alpha minima routing algorithm, which is used for transmitting the data from source to destination in efficient manner. These are my modules. In my project, I have 5 modules. The first module is power construction using directional antenna. Second module is limited virtual backbone construction. Third module is node prediction. Fourth module is node association. And the fifth module is routing generation using alpha minima routing algorithm. This is my first module. In my first module, power construction using directional antenna. In this, I am using directional antenna for transmitting the data. Why I am using directional antenna means normal antenna transmits the signal equally in all the directions. So the power and the bandwidth are get wasted. For avoiding that, only I am using directional antenna. The directional antenna has 2 modes, power on and power off mode, and also it is divided into 4 sectors. Each sector represents the direction. Then I am transmitting the signal in particular direction. How I am transmitting the signal in particular direction means, if I don't want to transmit the signal to forest region means I can off the signal in those regions, so the power and the bandwidth are not get wasted. By using on-off mode, I can on-off the power. And my second module is limited virtual backbone construction. For constructing limited virtual backbone, I am using iterative and adaptive algorithm. For that, initially I am finding the nodes. How many nodes are available. Initially I am identifying the number of nodes. Then I am predicting the possible paths between the nodes. After finding that, I am constructing the backbone between the nodes. Then my third module is node prediction using adjacent nodes. How I am predicting the node means, I am using genetic algorithm which is used for node prediction. Initially I am sending request to the nearest node. After acquiring the acknowledgement, I am extracting the IP address from that acknowledgement, then I am analyzing the nearest node. Then my fourth module is node association. I am associating node using random greedy algorithm. For that, initially I am predicting connection in between the nodes. What are the possible connections are available between the nodes. After finding the possible paths between every node, I am associating the nodes. Then my final module is routing generation using alpha minima routing algorithm. For that, I am optimizing the node. After optimizing, I am analyzing what are the possible paths available between the source and the destination. After analyzing, I am optimizing the path between the source and the destination. After that, I am transmitting the data from source to destination in efficient manner. These are my sample coding. This is a screenshot. The yellow color node represents the normal antenna. The normal, if we transmit the signal by using the normal antenna means it will transmit the signal equally in all the directions. The green color node represents the forest region. The red color node represents the city region. Now, if we transmit the signal by using normal antenna means it will transmit the signal equally in all directions. The green color and the yellow color nodes are receiving the signal. So the power and the bandwidth are getting waste. Here see the normal antenna transmits the signal to all the regions, the forest and the city regions. The black color node represents the signal receiving node. It is commonly transmitting the signal. So all the nodes are receiving the signal, so the power and the bandwidth are getting used. In this, I am using directional antenna for data transmission. The red color node represents the forest region. The black color node represents the city region. The black color nodes are receiving the signal. The yellow color nodes are not receiving the signal. So the power and the bandwidth are not getting used. It does not transmit the signal equally in all directions. This is my virtual backbone construction screenshot. In this I am constructing more number of virtual backbones. So the topology change is very difficult, and also the conflicts occur, and also if any error occurs between the nodes means it takes more time to find out the error. The yellow color node represents the fault tolerance node. If any fault tolerance occurrence means it's very difficult to find out. So in this I am constructing only limited number of virtual backbones, so it does not require more cost, and also it does not occur conflict, and also if any fault tolerance occurs, we can able to clear the fault tolerance easily. In this I am transmitting the signal between the source and the destination using the directional antenna. In this I am predicting the adjacent node. How I am predicting means, initially I am sending acknowledgement to the nearest node. After extracting the acknowledgement, I am finding